So you're planning an AI model project within the DPUK data portal. Well, there's a few things that we need to run through with you first so that you understand the concerns and risks in AI models and how they can be safely mitigated to ensure patient privacy is protected. Now, the DPUK data portal is a trusted research environment built on the 5SAFE framework. This means that only safe researchers are allowed access to the data portal, that their projects are done within the public benefit, that any research is done on safe anonymized data and takes place within secure settings, and that any outputs generated from that research are checked to ensure that they can be safely released from the data portal. Now, as this Swift safe, the safe outputs, which means that there's a heightened sort of concern around AI models and how we can safely determine that they can be released from the data portal. These present a lot more unique challenges compared to typical files like graphs and figures and tables, where we can actually look out for identifiable information. In AI models, they're essentially black boxes where we can't open them up and take a look at what could be identifiable. And so we need to ensure that any AI models requested out of the portal are being requested in a safe way which protects patient privacy. Most researchers aren't even aware of the risks that their AI models pose to patient privacy. If we take something as simple as an instance-based model, something like a support vector machine, then these actually store instances of the training data within the architecture of the model to be able to make predictions on new instances. And so this means we're actually storing data within the model itself. So if we share or transfer that model, we're actually sharing the data that was used to train it as well. So that means I could take that model and extract specific data about the patients used to train the model, which, of course, for us as a trusted research environment, we do not want to be able to happen on our data. So those are the issues with instance-based models. But how about other types of models which, rather than storing instances of the data, learn the patterns and properties of that data instead to be able to make predictions? So let's take a look at an example of an attribute inference attack. In an attribute inference attack, we might know some attributes about an individual already, and what we're trying to do is infer the attributes that we don't know. So say we know some variables about someone, their age, their sex, and whether they have dementia or not. We can query the AI model with random combinations of the variables that we don't know, along with the variables that we do know, and exploit the confidence score to try and retrieve the attributes that we don't know about a person. So by trying out lots of different combinations of the attributes that we don't know, if we observe the confidence score and see an increase in that confidence score, then we can see that those attributes are more likely relating to an individual in the training dataset. And so it's a feature of AI models that if you observe a very high confidence score, that it's likely it's seen that sample before in its training dataset. And it's that we exploit in an attribute inference attack to be able to increase that confidence score, to be able to infer attributes that we don't know. There's a number of different privacy attacks as well, rather than just the attribute inference attack. We have membership inference attacks and also reconstruction or inversion attacks. And depending on the types of data and models that you're using, these can have varying degrees of success to be able to attack patient data. Of course, there's also vulnerabilities in AI models which can make these attacks more likely to happen. If you have a model which is overfitting, so memorizing specific instances of the training data, then it's more likely that that model will be able to be attacked and you'll be able to extract instances of training data. If you incorporate things like explainability in your AI model as well, then this is something that adversaries could exploit to be able to refine their attacks and gain patient data. So we really have to be careful with how we're developing our AI models and to ensure that they are not overfitting and that the explainability that we give to them means that they can't be exploited in this way to attack data. Now, of course, these concerns only apply if you plan on bringing your AI model out of our secure data portal. If you plan on just doing your analysis within the portal, then these concerns aren't a problem at all. It's only when you plan to bring them out of the portal that we start having concerns, as they could be attacked by adversaries to exploit patient data. So there's different reasons why you might want to bring out an AI model. One of the reasons might be to publish on a platform like GitHub for open and reproducibility purposes. Now, this is probably one of the highest risk scenarios, as it means that you're putting that AI model out into the public domain for anyone to query and exploit and use. And so in this scenario, we would suggest that you instead publish your model via our trusted research environment, where we can treat that AI model as derived from the original data, where researchers can apply and access that data within the secure environment. So that means that AI model is still accessible for other researchers to be able to use and validate and further train, but it means that it's kept secure within our servers for that purpose. Now, if you do want to bring that model out anyway, we would need to make sure that there's privacy-preserving techniques implemented on top of that. So this might be things like synthetic data or differential privacy or homomorphic encryption, where you implement techniques to ensure that there's a risk of re-identification is reduced in those models. Now, another reason why you might want to share an AI model is for external validation on different datasets. Now, in this case, you could bring datasets into the data portal to be able to validate your AI model, or you could use some sort of federation or federated learning to be able to use lots of different datasets from different sources securely and train your model within the portal without having to actually leave. And now the third reason why you might want to deploy a model is to implement it into clinical practice, into something like the NHS. Now, in this scenario, we can host the model within our secure servers through sort of an API, which can be queried externally. So we can host the model and you can have a query interface outside the model where you can send data in to query and get predictions back. So these are the different ways that we can release AI models securely from our platform. And depending on the scenarios that you need to release your model, we can choose the most appropriate one for you. Thank you for taking the time for watching our video on AI model risks in trusted research environments. If you want to learn more, you can read our report here.